Class 10th chapter 2 HOTS. The zeros of the quadratic polynomial x square plus kx plus k not equal to 0, a cannot both be positive, b cannot both be negative, c are always unequal, d are always equal. So let us solve this. So here we have to find we have to discuss about the zeros of the quadratic polynomial. So let x square plus kx plus k equal to 0, where k is not equal to 0. So using quadratic formula, therefore we will get x equal to minus b plus minus b square minus 4ac over 2a. So this will give us, this implies x equal to minus b. What is our minus b? That is minus k plus minus b square is k square minus 4a is 1, c is k over 2a, that is 2 into 1. So this will give us x equal to minus k plus minus square root of k square minus 4k over 2. So x equal to minus k plus minus, what we are getting here is k into k minus 4 k minus 4 over 2. Now k is not equal to 0. In this we can see clearly that if k equal to 4, if k is not equal to 0 but k can be 4, k is not equal to 0 but k can be equal to 4, but k equal to 4 is possible. Therefore when k equal to 4, what will happen? Roots are equal. Roots are equal. So that means here we cannot say that the option C is correct, because it says that roots are always unequal. Therefore option C is incorrect. Option C is incorrect. And now let us go in the case when k is not equal to 4. What will happen when k is not equal to 4? So when k is not equal to 4, then in that case we'll get then there will be two distinct roots. Then there are two distinct roots. Two distinct roots. See, let us move back. So this will become, because k square minus 4k, this will not become 0. This will become non-zero. And so what we'll have is two distinct roots, because k is not equal to 4. So that means only two things can make this 0. One is k equal to 0, another one is k equal to 4. Both are not possible. So that means k square minus 4k cannot be 0. And so there will be two distinct roots. So then there are two distinct roots, and do not write here real roots, because when k square minus 4k will be greater than 0, then only there will be real roots. And if k square minus 4k is less than 0, then the roots will be there, but they will be not real roots. So we'll simply write then there are two distinct roots. So that means what we have come to the conclusion that there are two distinct roots. So what we can say that option D is incorrect, because option D says that the roots are always equal, but what we are getting when k is not equal to 4, we are getting the roots are unequal. So that means option D is incorrect. So in this case, therefore in this case option D is incorrect. Option D is incorrect. Therefore what we can say that, therefore we can say that both option C and option D are incorrect. Therefore both option C and option D, both option C and D are incorrect. Now let us move to this option A and B, whether let us check whether they are true or not. Option A says that both the roots cannot be positive, and option B says that both the roots cannot be negative. So let us check it out whether this is possible or not. So in this case, let us find the sum of the roots. So here, uh, let alpha and beta, let alpha and beta be the roots. Let alpha and beta be the roots of the quadratic polynomial, be the roots of the quadratic polynomial, quadratic polynomial x square plus kx plus k. Therefore, what we can say that alpha plus beta equal to minus b, that is minus b by a, that is minus k by 1, that is equal to, therefore we can say that alpha plus beta equal to minus k, and alpha into beta equal to c by a, that is k by 1, so that is alpha into beta equal to k. Now what is given to us is k is not equal to 0. We have k is not equal to 0, so either k is greater than 0 or k is less than 0. So let us now take in these two cases. Case 1, k is greater than 0. So in this case, let us do this case the next page. Case 1, k is greater than 0. So what we are having is alpha plus beta equal to minus k, and alpha into beta equal to, let's move back, alpha into beta we have got as k, alpha into beta equal to k. Now alpha into beta equal to k, that means alpha the product is this implies that the product of the two roots, product of the two zeros, the product of the two zeros is positive. This is possible only if, this is possible only if alpha is greater than 0 and beta is greater than 0, or alpha is less than 0 and beta is less than 0. Now, but what is the sum? The sum here is alpha plus beta, that is equal to minus k, that is negative, equal to negative, because k is positive. But sum of alpha and beta, but sum of alpha and beta is negative, and this is possible only if, and this is possible, and this is possible only if when it is possible, the sum of two numbers, if both are positive, it is not possible. It's possible only if alpha is less than 0 and beta is less than 0, because we have only two cases. One is alpha is less than 0 and beta is less than 0. Another one we are having alpha is greater than, beta is greater than 0. So if both are positive, their sum cannot be negative. So only possibility is, the only possibility which we are having is this one, that is alpha is negative and beta is negative, then only the sum can be negative, but we multiply them, we get a positive number. So it holds true for both. Therefore what we come to the conclusion that alpha is negative and beta is negative when it is possible, when k is greater than 0. So when k is greater than 0, both the roots are negative. So this is our first one. Let us give it as first one. So this is what result 1, this is our result 1 which we have got from case 1. Let us go in case 2. So case 2 now, case 2 will take k is less than 0. In the same, again like in uh, case 1 we have done, we will get the same result. So alpha plus beta equal to minus k, and alpha into beta equal to k. Now here minus k is this is negative, k is negative, so minus k will be positive, because negative of negative is positive, so this is positive, and alpha into beta equal to k, that is k is less than 0, that means it is negative. And so this implies this is possible only if this is possible only if this is possible only if alpha is greater than 0, one of them is positive, alpha is greater than 0, and beta is less than 0, or alpha is negative and beta is positive. Here there is no contradiction, because when we add one positive and one negative number, for example 7 and say minus 3, then 7 plus minus 3 equal to 4. So the sum of a positive number and a negative number can be positive, so there is no contradiction here. So this is our let this be result number 2. So therefore from 1 and 2, we conclude that the roots of the quadratic polynomial, quadratic polynomial when k is not equal to 0, here what we see that alpha, one of the roots is negative, and if we move to the earlier result, we see that both the roots are negative. So that means it is never true that both the roots will be positive. So from 1 and 2 we conclude that the roots of the quadratic polynomial k not equal to 0 are such that the roots alpha and beta, both can never be positive, both can never be positive. So that means either one of the root will be negative, either one of the roots will be negative, or both the roots will be negative, either one of the roots will be negative or both the roots will be negative. So therefore we come to the conclusion that, so let us move back the question. What is option A? Both the roots cannot be positive. Option B, both the roots cannot be negative. We have seen that both the roots can be negative, that means option B is false. And what option A says, that both the roots cannot be positive, so that means it is true, because we have seen that one of the roots has to be at least negative. So of all the options, options A is only correct. Let us write down this: either one of the roots will be negative or both the roots will be negative. Therefore option B is incorrect. Option B is incorrect, and hence of all the options, only option A is correct. Only option A is correct. So this question can be rewritten also. Suppose they write the same question, instead of this one they can write here, can both be present. This can not both be negative. In place of that they can write can both be negative, and here they can write can both be positive. In that case option B will be correct, because it may be possible that both of the roots can be negative. This can be negative, means not every time it is. There is a possibility of both the roots being negative, but not always. Sometime it is possible. Here is at no time it is possible that both the roots are positive. So with this, the answer of this question is complete. A is correct, B is false, D is false, C is false. So this is complete now.